have Jonas, who'll be talking about zebras and lasers. So I'm not really sure what that's about, but let's find out.
I'm Jonas. I'm Jonas. I use Python to write software for factories. And when you do that kind of thing, you quickly realize one thing. Your software is stuck in a box. And it really struggles with identifying like real-world objects, physical objects in the real world. And that's why we, the humans who love software, have sprinkled little helpers all over the world to make an easier life for software. So you guys carry a credit card so you can be tracked every time you swipe it. Your car has got a fast track, so every time you drive through the toll booth, and some other places you get tracked. And everything in my factory or in a distribution center has a barcode to make it trackable and visible to software. So this talks about zebras and lasers. This is the zebra, this is the laser. For the next 5 minutes, we're going to talk through absolutely everything that happens when that barcode reader says, beep. It all starts with some data acquisition. So what it looks like is there's these lines of the laser, but in reality, if you slow down time, you only see a laser point, and it's slowly, steadily traveling, and it records zeros whenever it sees white, and then it gets to the first black, and then it records ones, and then it just keeps going until it reaches the end of the barcode. That's the data acquisition step. And immediately when you look at that and run that, you realize you've got a problem because this is the real world. There's noise in your data. We need to do something to work through that. Let's do some image processing. People hear image processing, they think OpenCV. I hear image processing, I think list comprehensions. Because really what all that image processing is writing little functions that look at a couple of pixels, in this case 3, and implement a very simple rule. Like in this case, we're looking whether the surrounding pixels are the same and the inner one is different. And if that's the case, we keep it, otherwise we switch it out. So here's our kernel. That's what you call these little functions that look at windows. And then we want to look at a sliding window over that string, over our image. So how do we get to those windows? Let's see, we want to have 3 pixels in every window, and we want to get it out of that data that we just analyzed. We used a zip function to actually zip multiple copies of the data together, just offset by 1 pixel each. So we've got these windows here. We've got the first pixel, the second, and the third, and the first row, the second, third, and fourth, in the next row, and so on. We just apply our kernel function to each one of those. We get them shrunk. And I think we should call this smooth, because that's basically our smooth or blurred data that we're getting back. And this is what it looks like. All the noise is gone. So step 1 to processing barcode has happened. We know the individual pixels, but that's clean data, not useful data, right? So what we really want to know is how many of those like-colored pixels are next to each other. We want to group them. So Python, as you all know, batteries included. We're going to use like one of those slightly more obscure things from the itertools library. It's actually called group by. It does exactly what it says, or so. Actually, what is that? Let's look at what's coming out of that weird little iterator here, and let's get our parentheses. Oh, these are the groups. So it's telling me there's a group of zeros. The group looks like that. I don't care about what the group looks like. I care about how long it is. So we have 9 zeros, 8 ones, 4 zeros, and so on. Actually, that sounds right. Let's trim off the first and the last one, because they're just a white space around the barcode. I don't actually care too much about the label, so let's get rid of that. The barcode might be inverted anyway. And then I came prepared. I read the Wikipedia page on barcodes before I came here. I know that the barcode should start with a white bar, with a black bar that's 2 wide, and with a white, and followed by a white bar that's 1 wide. So it really looks to me like maybe we recorded 4 pixels per barcode bar, and then we've got some noise, and that's just the real world saying hello. We'll quickly round that away, and then we make it look nice by making it a string again. I hear that the keynote speaker today has the power to make string comprehensions show up in Python, so maybe that would be something to do next time around. I'm going to call this bars because that's the width of those bars. Now we've got something really good. We've got 2, 1, 1, 2, because the first one is 2 white, then followed by a white of 1 width, a black of 1 width, and a white of 2 width. What we want to do is go to this Wikipedia page that I've got open, look at that table of barcodes, which actually has the same kind of data at the end. And we want to look up what we have. So we need to chunk it into little chunks of 6. And as you know, chunks, we have batteries included. They're these super intuitive Python functions that come with a standard library that let you break strings into chunks. And then we make it look a little nicer, and now we can look them up. What is this character? Let's go to Wikipedia, find out. It's the start. That's good because it's the first one. Let's look what the last one is. That's a stop. That makes sense. It's beginning and end. We ignore this one because we are a very rushed barcode reader right now. The first letter, let's look it up. It's a P. I can see where this is going. This is a Python meetup. Let's see what the second character is. It's an H. Wait a second. What is happening here? What's the third one? That's another P. Our barcode reads PHP. And you guys just learned the most useless life skill. You can now read barcodes without a barcode scanner.